Hello students. Today we will discuss about problem based on examining whether a rational number has terminating or non-terminating expression. In class 9th we have the division and we find out the rational number is having terminating or non-terminating decimal. Like the examples which is on your screen. The first number which I have is 4/3. और अगर आप इसे डिवाइड करेंगे सो यू कैन गेट 1.333 और यू कैन से 1.3 बार. द सेकेंड एग्जाम्पल इज 29/7. अगेन व्हेन यू डिवाइड इट सो यू कैन गेट 4.142857. 142857. Again this is a reoccurring number. Please take care of the denominator of both the example. The first one is having the denominator 3 and the second one is having 7. Let's take two more example. The first one is 2/5. When I'll change it in decimal form, it will become 0.4, and 87/10, so it will become 8.7. Now you can check the last two and these two that both are having the denominator different. Here I have 5 and 10, and 10 is having two factors 2 and 5, and I can keenly observe that in previous question I have denominator 3 and 7, and here I have the denominator 2 and 5. It means if I summarize my all the conversation, so I conclude that if a denominator is 2 or 5 or both or single one, either 2 or 5, so I'll definitely get a terminating decimal number. So let's conclude. It is easiest thing for us that whenever I have 2 or 5 or both as the denominator, so I get the terminating number. So let's summarize it. If denominator q has a prime factor other than 2 and 5, then p by q has a non-terminating repeating decimal expansion. Otherwise, it has terminating decimal expansion. So that is the conclusion, and we will use it to solve the question of today's assignment. The first question is in front of you, which is write down the decimal expansions of the following numbers which have terminating decimal expansions. I have to give the decimal expansions only of that number which will give me terminating decimal expansion. So I should attend this question with the shortcut trick. First of all, I'll find out that whether the denominator having the factors 2, 5 or both. So I can easily get my answer that of which question I have to write down the decimal expansion of, or which question I don't want to write down. So first of all, I would like to start with 35/50, and to get the factorization I have the easiest method, which is prime factorization, or if you are capable to do it orally, so you can do it. 7 into 5, this is the numerator, and 2 into 5 into 5, this is the denominator. But don't be in hurry. जल्दबाजी में आंसर नहीं देना कि 2 into 5 into 5 है तो that is a terminating decimal expansion. Be careful. You have to cut numerator and denominator if they are having a common factor. Here I have a common factor 5. So I'll cut 5 and 5. Now I am getting the co-prime number 7 in numerator and 2 into 5 in denominator. Now I am confident that it is a terminating decimal expansion, and I know that 7/10 will give me 0.7, so I can write it directly. Now I should start 29/243, the second one question. Again I know that 29 is a prime number, so there will be no factor at all, but 243 I can break in factors, which is 3 into 3 into 3 into 3 into 3, 3 raised to the power 5, and I know that if I have denominator 3, so that is not according to the question. Since denominator has a factor other than powers of prime numbers 2 and 5, therefore rational number B will have non-terminating repeating decimal expansion. So I need not to write down the decimal expression which is indicating in the question. Let's start with the third part, which is 13 upon 3125. As we know that 13 is a prime number, I have to do the prime factorization of 3125 and I can get 5 raised to the power 5. Again I have the number 5. It means that will give me the terminating decimal expansion. Since denominator has no prime factor other than 5, hence decimal expansion of C will be terminating. Now you have to write down the decimal expansion of this question. So you need not to go to the long way. Again you have to use the shortcut method. How? I'll show you. I am putting 2 raised to the power 5 in numerator as well as denominator. If you cut it, so it will again become the question which is 13 upon 5 raised to the power 5. But I'll use this 2 raised to the power 5 to get my answer easily. By multiplying 2 raised to the power 5 in numerator and denominator, in denominator it will become 10 raised to the power 5. And I know that there are 0 5 times, so I have to put the 0 from the right to left counting 5 digits. So I'll start counting and I'll put decimal and my answer will become 0.00416. That's it. Let's start with the fourth part. In this part I have 15 upon 1600. In this question again I have to do the factorization of numerator as well as denominator, and after factorization I get, now the factors which I get here is 3 into 5 upon 2 raised to the power 6 into 5 raised to the power 2. But before coming to the conclusion, first of all you have to cut the common factors you have. Here 5 is common, so we will cut 5 and 5 and we get 3 upon 2 raised to the power 6 into 5. It means that the expansion will come which is terminating, and we have to use the shortcut method to get our answer. Here if I'll make 5 raised to the power 6, so I can get 10 raised to the power 6 easily. So I'll make 10 raised to the power 6 as I have done in the previous question. So I multiply 5 raised to the power 5 in numerator as well as denominator, and denominator because already is having 1 5, so by adding 5 raised to the power 5 power 5 with 5 raised to the power 1, so it will become 5 raised to the power 6, and as a decimal expression we can get the answer 0.09375. Now let's take the next one, and in next one we have 625 and we know that it is 5 raised to the power 4. Up till this I can find out that this expansion will be terminating, but the next part of the question is to change it in the decimal form. So again I will use the same shortcut method which we have used in our previous parts. So to make it 10 I have to multiply it with 2 raised to the power 4 with numerator as well as with denominator, and after multiplying the numerator will become 233408, and by putting decimal from right to left after counting 4 digits, so it will become 23.3408. Let's start with the next one. Now in this one we are having the question that without actually performing the long division, state whether the following rational number will have terminating decimal or non-terminating repeating reoccurring decimal expansion. So it's a easiest question because we know if the denominator is having 2 or 5 or both, so that will be the terminating decimal, otherwise it will not be. So the first part is having factorization भी करा हुआ है हमारे लिए 2 raised to the power 3 and 5 raised to the power 2. Since 23 is a prime factor, therefore no factor of the denominator can be cancelled out. ये ज़रूर चेक करिएगा. आप अगर फाइनली आंसर बता देंगे विदाउट चेकिंग दैट देयर इज़ एनी कॉमन फैक्टर और आपने कैंसिल करना भूल गए, सो डेफिनेटली यू कम टू द राइट not the right answer. So be careful about it, that before giving the answer, check it out that is there anything which is common in numerator and denominator. So here I have Q, no prime factor other than 2 or 5, therefore rational number A will have terminating decimal expansion. Let's start with 15 upon 1600. Again 1600, by taking the prime factorization, we get the prime factorization which is 2 and 5, 2 raised to the power 6 and 5 raised to the power 2. By cutting, it will become 3 upon 2 raised to the power 6 into 5. Since the denominator has no prime factor other than 2, 5, therefore given rational number B will have terminating decimal expansion. The same process we will follow with the third one, and in the third one we are having one of the factor which is 3 raised to the power 4. It means denominator is having a factor 3 other than 2 or 5. It means we have non-terminating repeating decimal expansion. So there are two more example. In the last two question we are having the denominator 2, 3 and 5. Again it is having 3 rather than 2 or 5. So it will be non-terminating, and in the last one we are having a factor which is 7, but be careful that 7 can be cut, and after cutting we get the denominator factor which is 2. So finally we can give the answer that this is a terminating decimal. So the conclusion is that to find out the whether given rational number is terminating or non-terminating, you have to take care of only the denominator should have the factors 2 or 5. That's it. So you can learn, you can do the practice of number of question by keeping only this simple view in your mind. I hope so you enjoyed it. Thanks for watching. Please like, share and subscribe for more videos.